Okay, so welcome back. This is part 14 in our series where we show you how to program your bench test instruments like your oscilloscope and your signal generator. And we have developed this application you can see here. We use Visual Studio and we use C#. You can use whatever IDE and programming language you want. But we've developed this application, and I encourage you to look at the previous videos in this playlist to show you how to get to this point. Now, this application does a lot of cool things. It allows you to control your signal generator and the oscilloscope. And we started out giving it the ability to perform a frequency response analysis where it would vary the frequency of the signal generator output and apply that to your circuit, and then you measure the output voltage on your scope and grab those frequency and voltage values and plot them to give you a frequency response graph. In subsequent videos, we showed you how to basically grab whatever waveforms are shown on your oscilloscope display in real time. And you can see here, we've got my Rigol DS1054Z with waveforms coming in from my signal generator onto channel 1 and channel 2. And this application is mirroring what you see on the scope, and it's doing it in real time. We're capturing every 0.2 of a second. And you can see we've got 2 channels worth of data. I can disconnect channel 2 and only show channel 1 and vice versa. We're asking the oscilloscope what's the frequency of the waveform on channel 1, what's the peak-to-peak voltage that you measure on channel 1, and the same for channel 2. And what we're going to do in this video is we're going to add some more functionality. And you can see down here in our application these 2 left and right arrows. And they're going to allow us in real time to change the X timescale values on the scope so that we can update this. So let's say we want to zoom in a bit on these waveforms. We'll hit this left arrow and watch the scope. Hit the left arrow and you can see we're updating both of these in real time. And hit the left arrow again and it's updating, and again. And you can see that we are now controlling the scope in real time. Now, I've also added a button up here that we will briefly touch on in this video called auto scale. So what is auto scale? Well, you can see here we've got a whole bunch of waveforms. We're zoomed out a lot. And usually in the real world, you don't want to see all this. You want to focus in on maybe 10 periods of the waveform. You just want to see 10 waveforms. You don't want to see everything all scrunched together, and you also don't want to see totally zoomed in so you can't even see a waveform, like if you're here. The purpose of this auto scale is to always give you about 10 waveforms worth of data. So I'll hit auto scale, and you can see it updates the scope, and it then reads what the scope is showing and updates it here so we can see 10 or 12 waveforms. So that's the auto scale feature. But first we're going to look at these zoom in and zoom out X timescale adjustments that we can do in real time. All right, so let's look at our application and try and figure out how we're going to design this. What do we need to do to implement this functionality of these left and right arrows? Well, if you think about it, this is no different really from taking the horizontal timescale knob and turning it on your oscilloscope on the front panel. So when we click this right arrow, it's like turning the knob clockwise. And in our case, we click the right arrow, and what that does is it makes the time scale, the seconds per division, to be larger. So they represent more time. So you're kind of zooming out. On the left, you're turning it counterclockwise, and it is zooming in. It is making the time scale, the seconds per division, less. So now how would we do that? Well, somehow we have to know, first of all, what is the existing time scale, right? In this case, it's 50 milliseconds per division. Here's 50 milliseconds, 100 milliseconds, and so on. So we first have to know what's the existing, and then we have to know what is the next available time scale in each direction. So if we're going to zoom out, what's the next available time scale? Well, if you notice on this particular scope, and it says in the programming guide that these go in steps of 1, 2, and 5. So it will go from 1 millisecond to 2 milliseconds to 5 milliseconds to 10 milliseconds to 20 milliseconds to 50 milliseconds, all right? It's all in steps of 1, 2, and 5. So that's going to make it a little bit difficult, right? If we're going to go in these weird steps of 1, 2, and 5, we can't make like a simple algorithm in C# that jumps to 1 second, 2 milliseconds, 5 milliseconds, 10 milliseconds, 20 milliseconds, and so on. That's going to be a little bit difficult. So how are we going to know what the available time steps are? Well, one thing that I did is I made a CSV file that lists all the available time steps. And the reason I did that was because it will also help with this auto scaling. So let's look at the CSV file I put together, and we can use that one CSV for both the auto scaling functionality and this time step adjustment. And here is the CSV. And this is basically, each row has two values. One is a frequency value, comma, a time step value. And you can see the first time step value, this is 1 nanosecond. So it's 1 nanosecond, 2 nanoseconds, 5 nanoseconds, 10 nanoseconds, 20 nanoseconds, and 50 nanoseconds. The first value is a frequency value associated with that time step. So what does this frequency value mean? Well, if we're going to auto scale, what we want to do is we want to measure the frequency of the waveform so that we can determine, well, if this is, for example, a 10 kilohertz waveform, what time step setting on the X scale do I need to give me about 10 waveforms on this display? So I'll hit auto scale, and you can see 10 kilohertz, it's setting up 100 microsecond per division. And it calculates, okay, I've got 10 kilohertz. If I have 100 microseconds per division, it should show me about 10 or 12 waveforms, 10 or 12 periods. This first number tells you for a 1 nanosecond setting, that will give 10 periods of 833.3 megahertz. So then you can go through, you can step through this and say, okay, I've got 10 kilohertz. So what I would do is I would scroll down to where I get around 10 kilohertz. So here's 16.6 kilohertz. Here's 8.3 kilohertz. I know I'm right in the range of either a 0.00005, which is 50 microseconds. So I can be 50 or 100 microseconds, and that'll give me somewhere around 10 waveforms at 10 kilohertz. So that's the purpose of this file. But also it gives me all of the possible settings. I went through and found all the possible settings and wrote them here. So this is going to be a dual purpose file. I can use it with auto scale, or I can just use a second value to tell me what are all the available time step settings. If I know what all the possible time step settings are, all I need to do is say, okay, what's the existing time step setting? In our case, 100 microseconds. You can see the first division is 100 microseconds. What's the next setting? So all I have to do is go here and say, here's 100 microseconds. If I want to zoom out, I will go to 200 microseconds. Remember we said it's a 1, 2, 5. So then I can look at these second values to get a list of all the possible values. So really, these arrows, all they do is say, okay, what's the existing microsecond setting for the time scale? And then with this one, I just go to the next one by looking in that list. With this one, I go to the previous one by looking at the list. And that's about it. The algorithm for this is really pretty straightforward. You're just going to have to look at that list, look at the existing setting, and go to the next one or go to the previous one. And then with the auto scale, you want to find out the existing frequency, which we're already measuring from the scope, and then look at the appropriate setting to get 10 cycles. Just basically go down through this list. So that's the logic. We're going to start out with these increment and decrement the X scale and see how that works. So what this for and if algorithm does is it's basically taking these right-hand values after the comma, which is all the possible settings of the dial, the X horizontal axis scale setting, right? It's taking the list that has all of these values and it's stepping through to find out where we are. So we've already found out what the existing scale is by doing this get scope value. And we're just trying to match that to this list of all the possible values. And for example, if we're at 100, we're at 10 kilohertz and 100 microseconds, then it's going to say, okay, here's our 10 or 100 microseconds right here. And it's going to say, okay, the next one is the next value in the list, which is 200 microseconds. So it's just going to step through all these values, look for the present one, and then based on that, it's going to find it and say, okay, here's the previous and here's the next value, all right? Very simple algorithm. So for all of those values, going to go through the whole list, if the measured scale is equal to the scale in the list, and we haven't already reset the X scale, then now we're going to set it. We're going to say X scale is equal to that value, that next value in the list. And then we're going to set this to true so we don't do it anymore. We jump out. And once we know what the new X scale is going to be, we're going to define a string called command scale, which is this time base colon main colon scale with a space plus whatever the new scale we want, which is this X scale to string. So we're appending the new scale as a double to this value. And this is not a scientific notation. This get scope value brings it out as a double. So here is the command all set to go. And then we call this set scope value. And it's just taking this value and setting the scale of the scope. So really pretty straightforward. You just measure it, look at the list, and then send the new value. And of course, the decrease is identical. However, it's using I minus 1, which is the previous value. It's using the exact same algorithm, but instead choosing the previous value so that you can zoom in. So that's about it. The logic is very simple, and you can see it works nicely in real time. So now another feature that would be nice is similar to this X scale increment and decrement. We'd like to do the same for the Y scale, the voltage scale. And keep in mind, there are now, since we have 2 channels or even up to 4 channels we can put into this, since we've got multiple channels, each of those channels can have their Y or voltage values changed individually. In contrast to the X or time value is only one setting. So we'd have ideally these arrows for the up and down of each channel. And we might look into that in the future if we get any interest. Unfortunately, with science and technology and engineering and software videos like this, there's really very, very little interest. Here we are in video number 14 in the playlist. I'm going to guess there's maybe 5 people on the entire planet who are going to actually follow this. So there's not a lot of encouragement to spend all the time to make these videos. Really, people just want cute cat videos and music videos, and that's about it. So I'm not sure where we'll go with this. But if you have any thoughts, if you have any comments, if you're actually here watching this, congratulations, you're one of the few people. Please leave a comment and let me know that you're actually watching this, and maybe there's one person on the planet who's actually doing this application to learn how to write software. One of the sad facts of our world today is that everybody is looking for AI to do everything for them so they don't have to think. With this stuff like ChatGPT that will write the software for you, you don't even have to think, and you can just sit back and play video games and not have to think. It's kind of sad that people think that all they want is entertainment and convenience, and they don't want to have to think about science and engineering. Let somebody else do it. So if you're not that way, and if you enjoy this stuff, let me know. I get very few comments over You know, the last 6 years and over 260 videos, I get very few comments. So if you like this stuff, let me know there's somebody out there who enjoys it. Otherwise, hit the like button, subscribe, hit the bell notifications, and most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.